Alright, hello. So in the previous video, we talked about using the keep, change, flip method to divide fractions, and today we're going to explore a little bit about why that process is true. So for instance, to remind you, keep, change, flip, if I have a fraction such as 4 over 9 divided by, let's say, 2 over 3, that will equal 4 over 9 times 3 over 2, which is equal to 12 over 18, which if you divide by 6 on the top and the bottom, you'd wind up essentially what I'm doing there is reducing the fraction at 2/3. Now we kind of just accepted this as true. However, we didn't really explain, well, why can we do this? And if you punch in your calculator, sure, that's a way to verify this will in fact be 2/3. However, let's see if we can find another way to get to this desired spot. So one thing I'd like to talk about today is dividing straight across. Some people don't know if you can do this. However, you absolutely can. If I were to take 4/9 divided by 2/3, just like multiplying straight across as we did towards the end there and a second ago to get, 4 times 3 equals 12 and 9 times 2 is equal to 18, you can divide straight across as well. So top divided by top, bottom divided by bottom. If you see this, well, what does this equal? Well, 4 divided by 2 is equal to 2, and 9 divided by 3 is equal to 3. And it's kind of nice about this particular example that we didn't even have to reduce, so it almost looks like we got to our answer a little bit more quickly. What I will say, though, is sometimes the numbers are not going to be as nice. So, for instance, if I were to do 7/11 divided by 2, let's say 9ths, why not? This guy we'd have turned into 7 divided by 2 over 11 divided by 9, and hopefully you recognize that neither one of these are necessarily nice numbers. I mean, the top one, it's like 7 over 2 is like 3/5, which is fine, but 11 divided by 9, it's a little bit harder to keep track of, and then hopefully you might recognize that it's going to be a little bit more difficult to see why or how easily what those numbers I just spoke will turn into 2/3. But let's go ahead and continue anyways. So, what I want to talk about is a little exploration of making this guy turn into our desired keep, change, flip strategy result of, well, 4/9 times 3/2, because, well, this is something that we can do dividing straight across. We can, if you verify in your calculator, well, 4 divided by 2 or any number divided by, you can do this you can do this process in your calculator and verify that yes, it is in fact equal to 2/3 dividing straight across. And we can show that we will wind up, if we were to divide straight across and mess things around a little bit, you will wind up at our little keep, change, flip result. So let's go and do this. So we have 7 divided by 2 over 11 divided by 9. I'm going to rewrite this as 7 over 2 divided by 11 over 9, making use of fractions because fractions are just much nicer to look at, if anything, if nothing else. What I'm going to do here is take our giant fraction and multiply it by 2 over 2. And the reason why I'm doing so hopefully become apparent in a second. Do note that 2 over 2, first of all, is the same thing as 2 over 1 over 2 over 1, because 2 over 1 is just 2. And we can do this, multiply by a number over itself, because this is the same as just multiplying by 1, ultimately. And if we do this, we see we have 7 times 2 over, well, 2 times 1 is just 2, over 11 times 2 over 9. Now, if I were to take 7, multiply it by 2, and divide it by 2, I really just am left with 7. And then in the bottom, I have 11 times 2 over 9. Now this is starting to look a little nicer, at least on the top. The bottom is still messy fraction. I'm leaving this 11 times 2, which makes it look a little bit messier too. However, we can really just continue this process, multiply this one by 9 over 1 over 9 over 1. And then here, I'm going to go ahead and swap things out. I'm going to move to the next row, and I'm going to be left with, well, 7 over 1 times 9 over 1 is just equal to 7 times 9. And the bottom we have, well, 11 times 2 times 9 over, well, 9 times 1 is just 9. Now, 11 times 2 is 22. If I take that, multiply by 9, and divide by 9, it's like I am just left with the 22 I started with. So I'm going to write this instead as 7 times 9 over 11 times 2. And then, of course, we can then undo the multiplication of fractions here that you might notice. You have 7 over 11 times 9 over 2. And hey, we have then gotten ourselves to the keep, change, flip, because look, we kept the first fraction, we then changed from division to multiplication, and then flipped the second fraction. And so if you were convinced about keep, change, flip, then hopefully this also links in your mind that yes, dividing by fractions is kind of the same thing. So you have two different processes that ultimately give you the same result. And then if you buy into dividing straight across, which hopefully you, it seems natural, just like multiplying straight across makes sense, hopefully. You can then follow that logic to get to the keep, change, flip end result, which is ultimately a much quicker mental process than trying to think through, okay, 7 divided by 2 is what? It's 3.5, and then 11 over 9 is what? And then putting those fractions on top of each other, or those decimals, 3.5 and whatever that is, and then trying to figure out that, oh, that's equal to 2/3, when instead you could just keep, change, flip, and get this guy is equal to, well, 63 over 22. So that's a little bit nicer in my opinion. And yeah,